Welcome to this week's lecture. This is lecture 6, and today the topic we will be looking at is transfer stations. So firstly, I want to put this the topic of transfer stations into proper context for you within the entire solid waste management process. So if you recall, from the start of the semester, we started we looked at solid waste generation. Now once we have generated solid waste, there are different points that we were looking at, for example, municipal, industrial, agriculture, etc. The waste must then be collected. So this is the point at which in the process the waste would be collected, and usually once the waste is collected, from our experience here in Trinidad, the waste would normally be transported to the final disposal site for us, which would be our landfill sites. But there are other options. For example, there is the option of having an intermediate point in the entire solid waste management process, where you can have transfer facilities where the collected waste can now be temporarily housed, and then from there it can be transported to the final disposal site, whether it is for whether it is for energy recovery or materials recovery, or alternatively the landfill recovery. Okay, so the topic of transfer stations that we're looking for at today is that intermediate collection point. Okay, so what are transfer stations? So waste transfer stations are facilities where our municipal waste is unloaded from collection vehicles. So we are familiar with these collection vehicles now. We have our various sizes and types of collection vehicles, and from there, once the waste is collected, they are briefly held at these collection facilities, where the waste is then reloaded into larger, longer distance transport vehicles at the transfer station. So the smaller vehicles, the loads would be loaded into a larger container, which would then be transported further distances, and those distances, the destination from that point would be to the landfill sites or other treatment facilities, as we saw in the previous slide, such as materials recovery facilities or energy recovery facilities. Now, why transfer stations? What are the advantages associated with it? So let's look at the first point. So by combining the loads of several individual waste collection trucks into a single shipment, communities can save money on labor and operating costs of transporting the waste to the final distant disposal site. So how can we actually save money? Remember, for example, the smaller trucks can hold less. That means they have to make more frequent trips to the landfill site. That means then that you have to spend money on labor. Each trip will require a crew. Additionally, there would be a wear and tear on the vehicles. There will be fuel costs, and all of these things will add up. So that means then that we have fewer trips, reduced number of crew sizes, and less fuel costs if we have to make shorter trips to this intermediate site where we would dispose of the waste into this larger container. So as mentioned before, the transfer stations, this will reduce the number of vehicle trips having to travel to and from the final disposal site. And there, at the same time, there's also the advantage where you now have the opportunity at this intermediate transfer station site, the opportunity to screen your waste before the final disposal. And what do we want to screen the waste for? We want to screen the waste to see if there are any components in the waste that could be recycled, could be reused, or if any of it could be used for energy recovery, etc. So all of this can actually be done at the transfer station before final disposal is carried out. Now what we are looking at here is a chart that compares the direct haul system to the transfer haul system, and we are comparing it in terms of cost and weight. Alright, now when we talk about direct haul, so that's our blue line. When we talk about direct haul, we are actually talking about the system that we are familiar with, where the collection vehicles, when filled, they will go directly to the landfill site. And the transfer haul refers to what we have already begun talking about in today's lesson, where we have that intermediate location where the waste would be deposited and collected, several loads of waste, and then eventually they would be transported to final disposal. So the point at which those two lines meet represent our break-even point, and this point is the point at which the cost of operations, or our expenses, this is where it is equal to the revenue, because remember, it is a business, right? So our cost represented on our y-axis, our x-axis represents the weight, how much weight, the weight in relation to the cost. So let's look at the direct haul first. The direct haul, we see actually the weight being equal between the direct haul and transfer, but notice at the beginning, when the weight is the same, when the weight is low, the tonnage, sorry about that again, the tonnage is low for both of them. Notice there's a significant difference in cost. So the transfer haul, the cost is actually much higher, and the reason for that is because the startup cost for the transfer haul would be associated with the startup cost of developing your transfer facilities. It would be very expensive. So in the beginning it would be a higher cost, but over time what we see is that though the each line actually shows an increase in the cost of the tonnage to transport the weight of the waste, we see that we have a steep increase for direct haul. So it continues to increase exponentially over time, while with the transfer haul we see that it is a gentle increase, and over time we actually find that the cost of operation for the direct haul will actually begin to exceed that of the transfer haul. And the reasons for that is, as we had discussed before, having to travel further distances, the vehicles, collection vehicles, having to travel further distances over time to make final disposal, you have increasing operational costs in order to have the sufficient crews, sufficient trucks, wear and tear on the vehicles, maintenance costs, etc. So what we find is transfer haul, it is a more expensive startup operation, but over time it is more economical than the direct haul. So with the transfer station now, you have to decide if transfer station is right for your community or for your country, and this decision must be based on determining if the benefits outweigh the cost. So for example, we say here that transfer stations generally become more economical when the hauling distance to the disposal facility is greater than 15 to 20 miles. Now that tells you in small islands like Trinidad, a transfer station may or may not necessarily be a wise choice, because for example, we have landfill facilities across Trinidad. There is in the north, in the west we have Beetham, Claxton Bay in serving the south area. Then we have Guanapo in the east, and then of course we have a landfill facility in Tobago. So across the islands we have some coverage. So the transfer facility may not really make a whole lot of sense in the sense that the distances that the collection services will have to travel is not that great, so it may not make financial cost for us. However, in larger countries, this may make a whole lot more sense for them. So let's look briefly at 3 types of transfer stations. The first one we are looking at is called a direct discharge transfer station. So in this transfer station type, the waste from the collection vehicles, they are emptied directly into the vehicle as a transport vehicle, and this is used to transport them to the final place for disposition, right? That's like your landfill site, for example. So these transfer stations, they are usually constructed in 2 levels, where you will have the collection truck would be on a higher level. On the lower level you will have the larger container where the waste would be emptied into. Alright, so that's really what we're talking about. Here I have a photo that actually illustrates for you how it's done. So the transport trailers are located in a depression. That's the trailer here. Notice this container is much larger than the collection truck that is on the level above. So what happens is the trucks would have access to the higher level, and they will come and notice the hoist truck system like what we have seen before, and it would be emptied directly into this container. Now again, as I said, notice the difference in size. So that means that this container is equipped to hold the load of several trucks before they actually make their way to the final disposal site. So this is the example of the direct discharge. Then we have what we call the storage discharge. With the storage discharge, your waste are emptied either into a storage pit, so that's a little depression in the ground, or onto a platform from which they are loaded onto the transport vehicle by various types of equipment. Excuse me. And the storage volume in this type of transfer station varies for about 1/2 to 2 days volume of waste. So in other words, they don't have to dispose of the waste every day. It can actually take time to accumulate over 1/2 a day to 2 days, depending on the capacity of the storage discharge. Here again we have an example, a photo example of what we're talking about. So on the left, this is where it is the waste would have been on a platform. So it's a flat ground area. You see the waste on the ground. Here you see one of the vehicles, pieces of equipment loading the waste from the ground into the container. Notice how large the container is. And then the other type of storage discharge, here we see a facility where you have pits in the ground. Those are depressions. Notice the containers to the side here. So what really happens is those containers, empty containers, would be loaded into the pit. The trucks will empty the waste into the containers that are located in the pit, and then the full containers would be lifted out and positioned on the trucks, attached to the trucks for final disposal. So this is what your storage transfer stations may look like. And then we can also have a combined direct and storage discharge transfer facility. So as the name suggests, this is where you have both types of facilities set up in a transfer station. And it's also important for us to know in the transfer station, you can have a transfer station designed in such a way that you have multiple facilities actually going on at that transfer station. For example, as I mentioned before, at the transfer station, you have the opportunity now before final disposal to actually investigate and sort material. So you can have salvage operations taking place there at the transfer station. So for example, sorting of your waste components. Remember, it's a lot of municipal waste we're dealing with, so you can have sorting of your waste components taking place there, so that you can separate, for example, glass from aluminum, etc., and these are all recyclable materials. Alternatively, you can identify waste that can be used for energy recovery, and you can have all these facilities also built in as part of the design of your transfer station. Now, that being said, I refer you to 2 short videos on the e-classroom where you can get a better understanding of what happens at some of these other facilities. So there is video 1 where you can see the title of the video is How a Typical Transfer Station Works, and then you will also see another video on how does material recovery facility work. Now, as mentioned before, this is one of those facilities that can be built in as part of the transfer station facility. Okay, now what are the main requirements of a transfer station? What are the things that we need to be concerned about? One of the first things we need to be concerned about is the capacity requirements of the transfer station. The capacity. So you have operational capacity must be such that the collection vehicles do not have to wait too long in order to unload, right? So it has to be designed in such a way that there could be smooth and easy passage through the facility. It must be logical and well designed. You don't want to have backup of traffic, because remember, particularly at certain times of the year in some country, or depending on location, if it's in a tropical country, you don't want to have the vehicles waiting too long because you're waiting in heat. Then you have buildup of traffic on the facility, so you have a lot of air pollution from the exhaust fumes and all of these things happening. So you don't want to have a situation where there is a backup. Additionally, in most cases, it will not be cost effective to design the station to handle the ultimate peak number of hourly loads. That's the maximum it can happen, because remember, this can there may be seasons where the loads might increase, but at the same time, what you don't want happening is that at other times when there is no experience of this ultimate peak number of loads, hourly loads coming in, you don't want the facilities left idle. All right, because when that happens, now it's you actually have a unnecessary cost happening there. It's an unnecessary expense. So what you have is, you want to make sure there's a trade-off between the time spent by the collection vehicles and the increasing cost of a larger station or more use of equipment. So what we're saying is, you don't want to spend money to put an unnecessarily large facility where most of the time the facilities and the resources are being left idle, even though there may be times when it may not be able to handle the peak amount of traffic. So then you have to make sure your design is very efficient in order to facilitate that as best as possible. Now the next requirement we want to look at is our equipment and accessory requirements. So we're looking at the types and amount of equipment at the facility, and these will vary again with the capacity of the station. So not only the capacity of the station in terms of how much it can handle, but what are your objectives, what you're really trying to do at the station. So the functions of the waste management system have to be considered. So one simple example as to what I'm talking about would be, for example, you may want to have scales. Remember in a previous lecture we talked about the scales facility that they would have, where the trucks, the loaded trucks, can drive onto these scales where the load can be measured, right? So you may want to have at your facility have scales provided at medium and large transfer stations. All right, and the reason for that, as we already know, is if you have scales, you're better able to monitor the operation and also collect meaningful data for strategic planning with regards to the waste management system that you have going in operation in your country or region. Okay, so equipment such as scales, you'd also want to look at vehicles, the storage capacity, all of these things, right? So this is very important when we are looking at transfer requirements. And then we also have to consider our environmental requirements. So most large modern transfer stations, they are enclosed and are constructed of materials that can be maintained and cleaned easily. So it's a large facility. It would tend to be walled or fenced around. The surfaces would be designed in such a way, as I said, it can be easily maintained and cleaned. The cleaning is necessary because remember, you have a lot of waste and a lot of vehicles coming in and out of the facility every day. All right, you will have spills and all kinds of things happening, so you have to be careful. You want to make sure that your facility has proper drainage, because when you clean, for example, you may have to power wash the facilities, etc. Remember, chemicals and oils and all kinds of things will be washing off of those surfaces. You don't want it draining into your soils. You don't want it draining indiscriminately, so you'd want to have proper drainage systems in place. Also, the direct charge transfer stations, some areas may be open loading areas, so you have to have things in place where light waste that could be easily blown about, such as paper, dust, etc. You want to make sure you have things in place that will contain the movement of this kind of waste, so that it doesn't go into neighboring communities or environmentally sensitive areas. So some of the ways that you can deal with this is you may install wide screens on the peripheries of the facility, or make sure that you have other types of barriers such as trees, etc. Okay, so environmental concerns with regards to the containment of the waste and the management of the waste, this is very important. So as mentioned, the design of your facility and the construction should always be such that all accessible areas where the rubbish or paper can accumulate, you want to eliminate it. So the design of the facility must be very carefully done, not only in terms of screens and barriers, proper drainage. You want to make sure that the road access in and out, the flow of the traffic is well organized. You don't want to have two-way traffic to cause backup. You don't want to have because at a facility like that you may have the general public coming in, so you'd want to make sure that there's a secure parking area for them where they don't have to come in contact with the collection vehicles that are coming in and out, because you may have facilities at your transfer station where private individuals could come and drop off let's say recyclables, etc. So you want to have accommodation for all of this. All right, and this has to be done in a wise way. Design your facilities in a wise way, and all of this is to avoid negative environmental impact. Okay, so let's talk briefly about the location of transfer stations. So we have some criteria we're going to look at briefly, criteria for siting or location of our transfer stations. And the first thing we want to look at is that your transfer station should be located as near as possible to the weighted center of the individual solid waste production areas, the waste generation areas, such as a community. So as indicated, let's refer to the next slide. What do we mean by the weighted center? So if you look below here, the definition says that the geographic center of a set of points as adjusted for the influence of a value associated with each point, right? So the influence of the value here, we're talking about population. So if we think about each of these points representing a certain number of people in a community, we see a big cluster in this area. All right, that means then from a solid waste management perspective, it means the largest amount of waste is being generated within that cluster. So what we want to do is we would want to set up our transfer station to be most easily accessible to that cluster, and the other areas would also be serviced by the transfer station, the more distant areas, but the heaviest accumulation of waste and the greatest requirement for waste collection would be in that cluster. So that's what we mean by you would want to locate as near as possible to the weighted center. Secondly, it should be within easy access of a major arterial highway route. So that's your major transportation route, your highway, as well as near a secondary or supplementary means of transportation. So you want to have access to that major highway route, which is likely going to be the route to take you to the landfill. But you also want to be near enough to one of the secondary roads so you can have access to the collection points, which would be your communities where that generates the waste. So that's a transfer station, a kind of intermediate location between your transportation routes. Thirdly, it should be where there will be a minimum of public and environmental objection to the transfer operation, because remember, the transfer operations would, firstly, it's going to be a lot of traffic, you'll have a lot of dust, and some of the things we mentioned before that would be a concern. There would be a lot of noise because you'll have a lot of trucks and other heavy equipment operating at the transfer station. So you don't want to be too close to any built up areas, any residential areas, because it will become a problem for them. The noise and the irritation and the annoyance. But at the same time, you don't want to be too far away from them, because distance becomes an issue now in terms of cost and operational convenience. Okay, so you want to be smart about where you're locating it, because you want minimum public and environmental objection. You do not want to be located too close to any environmentally sensitive areas as well. And fourthly, it should be where construction and operation will be most economical. For example, you don't want to go into an area that is hilly, because remember, transfer station, you're going to need space. It will need to be level. You don't want to have to go and excavate to level out the place now, because that will be costly. You don't want to have to go into for example, into a swampy area for you to have to fill it in. There will be high operational costs there, as well as environmental consequences. And lastly, we want to look briefly at 4 other methods of transfer of waste. We're going to look briefly at motor vehicle, railway, water, and one that we refer to as pneumatic. So the motor vehicle transport, this is the one we are most familiar with, transport for waste collection. So the motor vehicles, they are used to transport the solid waste on highways, and they should satisfy the following criteria. The vehicles must transport waste at a minimum cost. You're looking at cost here. So typically vehicles would be able to do this at a minimum cost. The waste must be covered during the whole operation. So I mean, I'm sure many of us would have seen examples of where we have seen collection vehicles in Trinidad that seem to violate this particular standard, but it is a standard. They must be covered because it can be dangerous when traveling on highways. Things could be flying out of the vehicle. It could cause accidents. It could injure other people, etc. Vehicles must be designed for highway traffic. So for example, the vehicles must be able to maneuver easily in highway traffic. Even if it's a large vehicle or a smaller vehicle, we have different size waste transport vehicles, but it must be designed for highway traffic. Because remember, when we're on a highway, usually the driving speed would be higher than that of the local road, so it must be able to maneuver in that kind of traffic. Additionally, the vehicle capacity must be such that allowable weight limits are not exceeded. Now, in relation to that point, please look at this note at the bottom here. The maximum volume that can be hauled in highway transportation vehicles depends on the regulations enforced in the jurisdiction within which they operate. So in other words, what we're saying is the capacity of the vehicle that is being used to transport waste, this must be dictated by what regulations in that particular area define, because you don't want to be violating regulations or laws by exceeding the capacity of the waste that you're carrying on your truck. And additionally, the methods used for unloading must be simple and dependable. So I mean, we looked at a couple of vehicles already over the course of the semester. For example, we looked at hoist truck and tilt frame trucks, for example, and we know that based on the design of these vehicles, once they have been loaded, when it comes time for unloading, it's a very simple process of activating the mechanisms in the truck so that the tray can be tilted and automatically emptied in another location. Then we have railway transport. So railways, this form of transport was more common in the past, but what we find is that now there is a renewed interest in the use of railway for hauling waste, and particularly with regards to waste generated in remote areas. What also happens is in these remote areas, they don't often have frequent and regular collection of waste. So what happens is, it means then that if it's not frequent, we have a buildup of waste, larger volume of waste over time. So now if we have railways facilitating these distant areas. Remember, with the railway now, you can have multiple large containers attached to the railway, and that means that larger volumes of solid waste from these remote areas could be now collected and transported for disposal, whether it is to the transfer station or the final disposal site. Then we have water transport. So examples of vehicles for water transport would be barges. For example, barges, we'll be familiar with these from the perspective of these are large flat vehicles that would often transport large containers, bringing in goods, etc. So it can be used for waste as well. Then we have scows, which are flat bottom boats, and other types of special boats that would be used to transport waste to processing facilities or to seaside and ocean disposal sites. Now it's important for us to note that ocean disposal is no longer commonly practiced, and the reasons for that is because typically what we found over the years is that, as we've already identified, we have a significant amount of waste being produced in developed countries, and these waste would often be shipped to developing countries via ocean transport, and the waste would often be indiscriminately disposed of in the developing countries, and much of this waste would be hazardous waste as well. You also have examples of ocean dumping grounds. You may have heard of examples of the Atlantic garbage patch, for example. They're almost like they're so large that they are like islands of waste floating in the North Atlantic. Different parts of the world we have examples of this, and these cause all kinds of problems for marine life, etc. And with regards to the dumping of hazardous waste shipped via ocean now in developing countries, we had a growing problem now where the hazardous waste had been indiscriminately disposed of. Environmental problems and widespread health problems resulting. So what happened is, in 1989 there was a Basel Convention where many countries came together in agreement that what they would do is they will commit to reducing, restricting and regulating the transboundary shipment of these hazardous waste. So what we have now is a greater emphasis that if shipment of these wastes have to take place at all, it must be done in a very highly regulated manner, where the shipping country and the receiving country come into agreement with regards to how the whole process would be carried out in order to contain and manage the transportation of the waste so that there's no danger involved, and also on the receiving country's end, what is going to be done about the waste? Is it going to be treated? How is it going to be treated? And additionally, this would also involve cooperation between developed and developing countries to make all of this happen. Okay, so this is the Basel Convention. I believe I would be making a link available on the eClassroom for you to do a little reading on that as well. And then we have the pneumatic transport, and this type of transport utilizes low pressure vacuum conduits or transportation systems, which may, for example, be like huge pipes. Usually these would be underground, they would be out of sight, and what it does is when you dispose of your waste at entry points, where the waste will then be sucked from that point and deposited in a collection system that will act like a transfer station in a sense, and then it would be transported to the final facility. So this type of transport system is a common application in the transport of waste from high density apartments or commercial activities to a central location for processing or for loading into transport vehicles. We have a couple examples of this. We have a large pneumatic system in use at the Walt Disney World Park in Florida. So as I described before, this is not a system where you will be seeing trucks. You won't see evidence of trucks. You may not even see too many bins and all of that around. Okay, so the system keeps, it's very aesthetic. It keeps the place clean and clear, because everything is designed, it's happening out of sight and underground. Additionally, a case study would be made available to you on eClassroom, where we have a pneumatic system also in use in the old city of Leon in Spain. Alright, so this is available on eClassroom. So I want to thank you for joining me for today's lesson, and can you please proceed to the activity for this week? Thank you.